ऑलराइट, वी आर लाइव नाउ। सो सभी का स्वागत है आज के इस सत्र में। सो वी आर ऑलमोस्ट ऑन द अर्ज ऑफ closing cover this visualization course. So extending what we have already done in last couple of sessions, visualizing the geometry and algebra in three-dimensional x, y, and z. So we started with looking at this three 3D solids, the cylinder, the cone, and the hemisphere, and we wrote a parametric equation for each of them, trying to visualize that how they are similar in the sense that it's circle on top of each other. वैसे हमने इसको देखने की कोशिश की. At the same time, on the last sessions, we have drawn a spring or a helix or a spiral on each of this 3D solids. आज जो है हम सिलेंडर को चॉप करेंगे, and we would like to look at the cross section properties of a cylinder. So जब हम 11वीं में पढ़ते हैं कि हम सिलेंडर को जब काटते हैं, no matter at what angle you chop, it would be always an ellipse. And the very first question comes to in mind that how do you prove that it would be an ellipse? Lagta hai doesn't mean it follows an ellipse property. The property of, or for me, the ellipse is nothing but a circle with two centers, isn't it? कि what is the circle? कि बीच में कहीं पे खूंटा गाड़ दिया when you have a center and a nail, and let's say some constant thread you have, and all the points which are equidistant from the center. That's how you define and a circle. Now imagine instead of a one nail, एक खूंटे की जगह आपने अगर दो खूंटे गाड़ दिए, and then you take a thread which is connected to both of this nail as well as, and then all the points which are equidistant from both these points. So this is nothing but all the points who have where these two are the centers and equidistant from these 2 points. This is how you define or trying to define the ellipse. One of the definition is that. Question is, where are these two centers of that conic section or that ellipse when you chop it from the cylinder? And this is what I wanted to show it to you. Let me share my screen with you. And here is a very beautiful proof by a dandelion, which says that कि यहाँ पे, let's say if you look at the cylinder, ये हमारा ब्लू कलर का है, वो हमारा क्रॉस सेक्शन प्लेन है. If I change the angle of a cross section, angle of a cross section plane, then you will see that the ellipse is getting changed. If I make it parallel to the base circle, then it would be a circle. Now, how do you get the two the focus points of this particular ellipse? And that's where a dandelion comes with an absolutely interesting definition of a or a proof part of it, where it says that कि एक focus point आप ला सकते हैं same diameter का sphere अगर सिलेंडर में डाल दें, wherever it touch that plane is one of the focus point. How about the other one? एक नीचे से डाल दीजिए, उस तरह से आपको दो focal points मिल जाएंगे. These would be the two focus points, and once you get that with this particular concepts, it's not so difficult to prove the constant distance wala property of an ellipse from these two focus points. And let me try to also show this in this particular. You'll see that this particular green point is the one of the focus point, and another focus point is where another sphere tangentially touch the display. कौन से दो फोकस पॉइंट्स हैं? आपने जहां से प्लेन ये जो काटा, वहां पे ऊपर से एक गेंद गिरा दी, एक नीचे से हमने गेंद को फिट कर दिया. ये दोनों गेंद ये जो क्रॉस सेक्शन प्लेन है जहां पे टच होते हैं, these are two focus points of the ellipse you are getting. So we can go and talk about the algebraic proof for that, but this visual part is something which appeals as a lot. And I'm keeping this as an homework exercise for you. Can you draw a cylinder and a cross section plane where within given option of an chopping it, here I'm only changing one of the angle. So angle with respect to, let's say for an example, an XY plane, that's what I'm changing. 3D में मैं एक ही एंगल को चेंज कर रहा हूं, and you'll be able to see the ellipse is getting changed the moment I make it. So this particular angle getting small and small, ये जैसे ही छोटा होता हुआ जाएगा, ये जो दोनों फोकस पॉइंट्स है वो पास आते जाएंगे. There would be a point come when this angle becomes zero, so as the distance between two focus points and my ellipse would eventually turn out to be a, because both these points are merging I mean merging to be a single point. That's why it becomes a one center ellipse, which is a circle, isn't it? Yeah, आपका circle बन गया. And this is the point where your both the sphere also are touching on the same location. All right. So I'm keeping this as an homework exercise for you. I have a cylinder, make a cross section for that, draw a plane into this, and enter a one sphere which tangentially touch this this particular plane, so as the bottom one. Can you try to do this exercise as an homework, and then eventually isko hum if you are not able to do that, maybe in the next session we would discuss. आज हम क्या करेंगे, आज इसको हम काट के हम ये वाला जो उसकी जो पिल है वो देखेंगे कि वो क्या होता है. So let me try to open that. What we wanted to do is, after making a cross section, we wanted to remove the pill of a cucumber. Yeah. मैं एक बार अपनी स्क्रीन शेयर कर देता हूँ. So here you have a let's say cucumber piece जिसकी रेडियस और हाइट बराबर है, और हमने क्या किया है, उसको एंड टू एंड कट कर दिया. What I mean by that is, you have started from, let's say if you consider this rectangle, one of the point for cross section is the one of the vertex of a rectangle from side view, and another one is the just diagonally opposite to that. वहां से हमने पास करता हुआ ये प्लेन ड्रॉ किया है. अब जो सवाल है वो ये है कि अगर मैं ये जो बाकी दो पीस हो गए, उसमें से किसी भी एक पीस का जो मैं छिलका उतार लूं, considering this as a cucumber, what would be the surface of that if I make it a flat thing? Question is, what would be that? So this is what we have, I believe we have at least discussed up to certain extent in the last sessions. Can you tell me what will be the peel of this? फिर से एक बार सवाल कर देते, क्या है, हमने एक सिलेंडर ले लिया जिसकी रेडियस और हाइट बराबर है. अब मैंने उसको एक टेढ़ा कट लगा दिया एंड टू एंड. मैं एंड टू एंड आई मीन I'll start at the bottom on the let's say for example let's just looking at the side, it's a rectangle, so one of the vertex, and then diagonally making that connection, it is passing from the opposite side of the vertex, वहां से निकल रहा है, ऐसे एंड टू एंड लगा दिया है. तो अब इसके दो भाग हो जाएंगे, एग्जैक्टली सेम दो भाग हो जाएंगे. लुकिंग एट द वन ऑफ द पार्ट, इफ आई ओपन द पिल ऑफ इट, would you like to guess what will be that shape? Any thoughts from the people who have so Upma ji feels it would be a triangle, so as Mahesh ji. Someone says rectangle. I'm not able to see whether. Okay, ठीक है. Somebody feels it's a rectangle. Rectangle, if you have not made a cross section. अगर सिर्फ सिलेंडर का छिलका उतार दे, then it would be a rectangle. But so most people, I mean, two participants feel that it's a triangle. All right. Let me see in the YouTube also. Okay. ठीक है. चलो. So एक बार करके देख लेते हैं. ठीक है. So now what I'll do is I will have one of this line मूविंग ऑन टू दैट पर्टिकुलर पिल एंड उसका जो प्रोजेक्शन है मैं 2D में यहाँ पे बगल में कर रहा हूँ. लेट मी प्ले दिस. So AB is the line segment which is on this particular pill. और वो उसको मैं 2D में जो है वो on the left hand side screen I have made the projection for that. Will you be able to now tell what is this shape? आप बताना चाहेंगे ये क्या है? क्या किया है हमने? ये कुकुम्बर का जो पीस है इसको हमने काट लिया. So if you look at the side view, it's a right triangle with the base as the diameter of a circle, base circle, the height as the same as the a cylinder's height, and this is the hypotenuse. That is from the side view. But what I am interested in or what I have asked is कि इसको जब हम flat कर दे, this is when you look at it from the side. This is one of the view. I am asking that कि when we open the pill, when we make it flat, वो जो छिलका है उसको उतार के मैं नीचे रख दूं, तब मुझे क्या मिलेगा? Now would you like to guess looking at this image? अशोक जी, you still feel that it would be a triangle या कुछ और है? It doesn't look a straight edge, it looks curved. It is a sinusoidal curve. ये एक साइन वेव है. अगर मैं यहाँ पे so current amplitude is 1 for this particular curve. If I draw a line at a 0.5, this is a shifted upwards. It looks like a bell curve, but it is not. It follows the definition of a sinusoidal wave. And today, what all we wanted to do is we wanted to prove that whatever this cross sections you have made, it is actually a sine wave. So we wanted to prove that what would be the height. So AB जो है उसकी height कैसे change हो रही है, आज उसको ढूंढने की कोशिश करेंगे. We would actually make this particular application today. All right. ठीक है. Any doubts or any thoughts you have so far? Otherwise, let's just start proving it, or let's start making it that how this will be a sinusoidal wave. It would require a bit of visualizations exercises. So my request to you is that just be with me, and whenever you have a doubts or you are not able to follow any single step, just let me know. We'd be more than happy to do. We don't want you to do anything for the next 30 minutes. All we wanted to do is prove that कि अगर मैं सिलेंडर में क्रॉस सेक्शन मारूं तो जो वेव फॉर्म क्रिएट होगी वो साइनोसॉइडल होगी. वो आज प्रूव करने की कोशिश करेंगे. इट वुड इन्वॉल्व सम ऑफ the 3D visualization exercises. So try to be with me, try to be there with me. We will try to construct this. All right. So starting from the very basic steps of how do you make an app on GeoGebra. So somebody who is connecting for the first time, GeoGebra पे कुछ भी बनाने के लिए you wanted to first go to this website name geogebra.org. वहां पे जाके आप क्लिक करेंगे. So if you have not already logged in or if you have not created your account, so maybe you wanted to create your account first so that all your work which you have done can be stored in your account. वो सारा काम आपके अकाउंट में स्टोर रहेगा और जब भी आपको अपना पुराना काम देखना है या किसी को भी रिफर करना है, सो दैट यू कैन एक्सेस दैट फ्रॉम योर अकाउंट. ऑलराइट. आपका जो भी काम है आपको देखना है दैट इफ यू क्लिक ऑन योर दिस अकाउंट आइकॉन ऑन द राइट टॉप, तो दिख जाएगा कि आपके जो जो भी आपने अभी तक का काम किया है वो आप इसमें स्टोर्ड हुआ हुआ देख सकते हैं. इफ यू वांटेड टू क्रिएट अ न्यू ऐप, then maybe you wanted to go to this GeoGebra's homepage and click on the start calculator. आप जैसे ही इसको क्लिक करेंगे you will see that there will be two windows. The one will be where this cursor is. It's command window. ये जहाँ पे हम अलग अलग कमांड्स लिखेंगे. On the right hand side what you see is a graphical window. जो भी आप कमांड लेंगे, जो भी कंस्ट्रक्ट करेंगे, whatever you have your algebraic part, its reflection would be on this geometrical, this graphical window. By मतलब मेरा अभी यहाँ पे 3D कैलकुलेटर था. If you wanted to do certain things on a 2D, then where you only wanted to use the x and y parameters, so that's where the graphing tool will help. आज जो है हम 3D cucumber को काटेंगे. That's why I have selected the 3D calculator app. Apart from the algebraic commands, you can also have a GUI tools. Let's say if you wanted to draw a cylinder, then maybe you wanted to create it by, let's say for example, this cylinder tool, and no, it's asking me that select 2 points and then enter radius. So let's say if I create the cylinder with origin as a one of the point, and another point is at the, let's say the height as 1, and the radius if I entered as 1, it would create this particular cylinder. This is also the way, but what I would suggest is, for some of the things you wanted to create, it's okay to use the GUI tools, but most stuff, the involved one which you wanted to create requires writing the algebraic expressions or relating the geometric understanding with the fundamental geometric understanding and writing commands for that. So that gives you a lot more powerful access to the things which you can do using this tool named GeoGebra. तो इसलिए मेरा आपसे सुझाव है कि कुछ बेसिक चीजों के लिए आपको GUI का टूल करना है, वो ठीक है, but let's say chopping the cylinder and then making sure that the point moves on and proving that it would be the height would be with respect to the change in the sinusoidal curve, उसको करने के लिए तो हमको कमांड ही लिखने पड़ेंगे. So it would be a nice exercise to do a stuff using command, but it's okay to use an GUI commands for no, for a sake of convenience. ठीक है, तो हमारा सिलेंडर तो बन गया. लेट मी वंस अगेन ट्राई टू create the same thing using command as well. तो उसके लिए कमांड क्या है? So command for that is cylinder. I want my cylinder to be on, let's say for example, I want it to be half distributed upon the XY plane. So I would like to have one of the center of the base circle as 0, 0. Its x and y coordinates are 0, but its height I wanted to keep it as -1. Similarly, I also want its the another point at 0, 0, 1, and the radius I wanted to have will be, let's say, 1. So this is how, let's say, I have created a cylinder. All right. It's getting. Now what I want is, I wanted to draw a plane making a cross section of this cylinder end to end. If you look at from the side view, I want it to be passed from the base circle on one of the point, and another cross section point where it is coming out would be the just diagonally opposite to that from the top base circle. कोई बताएगा कि how can I define that plane? मुझे क्या चाहिए? मुझे चाहिए कि ये जो सिलेंडर है उसमें से एंड टू एंड पास होता हुआ एक प्लेन पास हो जाए. So what I want is it should pass tangentially from here to here. If I would say, if I wanted to draw a plane, the command for the plane could be, one of the option can be, if I can tell the possible 3 points from in a 3D space, if I can define the 3 points, then also it can tell me that what would be that plane. Okay, so can somebody tell me these 3 set of points, which are preferably not the linear one, because agar linear points hai, so they cannot uniquely define the plane. So can you tell me exactly which 3 point I should tell such that the plane would be passed from the, I mean the cross section it should make would be such that it would be the my desired one. अब बता पाएंगे कौन से 3 पॉइंट मैं इधर दूं इनपुट में? All right. Yeah. Good to see some Delhi Asiatic folks. Yeah. All right. And of course, some from Gujarat, Telangana also have joined. Yeah. Yeah. Nice to see you all. जी, अभी मेरा क्या सवाल है? मुझे एक प्लेन ड्रॉ करना है जो इस सिलेंडर को काटे, कैसे काटे कि लेट्स से फ्रॉम द बॉटम सर्कल इट इज पासिंग टेंजेंशियली so as from the top circle it's passing just touching it, and both this cross section point are the diagonally opposite one. The question is, one of the way to define this particular plane is by giving 3 point, preferably not the linear one, so that I can uniquely define this plane. Can somebody tell me what are these possibly 3 points? What would be the bottom one, bottom extreme? What would be its x coordinate, y coordinate, and z coordinate? Z would be for sure. उसकी जो height होगी वो पक्का. हाँ जी, yeah, somebody was saying something. Yeah. So let's see if one possibility could be if I look at it from the top, it would be just a circle. Would be just a circle with, let's say for example, its x coordinate could be 1, y coordinate could be the 0, and height is of course the -1. So let me try to see if I can have these points as 1, 0, -1 as the height. What would be the top extreme point? It would be somewhere here. So then my x would just become negative, whatever the existing value is. The z would be, of course, now you are on the top of the xy plane. That's why the +1. What will be the third point? और कोई तीसरा point बता सकता है? One possibly could be origin में से वो pass होगा, वो वाला जो plane है. But then they would be all on the same straight line, and that's what not I want, because अगर मैं एक line बता दूं, then I cannot clearly define my plane in a 3D plane. So the another point I would take it, maybe it will also pass from this point. ये जब बीच में से पसार होगा तो वो वाला जो point है आप देखेंगे तो it would also pass on this location. Let me try to first see it from the top. जो XY plane है इसके यहां से भी पास होगा, where the y is 1 और -1, isn't it? और जहां XY plane है, मतलब XY plane है उसके ऊपर y की वैल्यू जो जहां पे 1 है, x would be 0 and z would be 0, वहां से भी वो पास होगा. So let me see if we are able to correctly draw this. Then x is 0, y is 1, and z is also 0, right? And now if you try to look at this, whether it is the one which we wanted or not. Yeah, Upma ji said 1 1 0. I'll come to that part. Kalpesh ji feels it's 1 1 -1. All right. Let's both of us let's try to see if both of the options. So now if you look at this, so, ठीक है. अब आप इसको देखें तो दिस इज ये वाला एंड टू एंड कट लगेगा. It's very problematic. All right. Upma ji said that uh, uh, one of the point why cannot be it be the 110. So 110 is where your so that's where it's on the xy plane, and so your 110 would be actually somewhere here. अगर आप टॉप से देखें, yeah. So your 110 would be somewhere here. Now on the xy plane. Now just also try to see that कि in fact that is also not lying on the surface of sphere. मैं एक बार draw कर लेता हूँ. It is somewhere here on your plane. It's definitely not passing from that point. Your plane is actually passing from the y-axis. Y-axis से pass हो रहा है, वहां से नहीं pass हो रहा है. If you make a change for that, so let's say if you make it 110, then your plane would be actually gonna shift it. और आपका जो कट लगा रहा है, that would be not a end to end one. आप देखेंगे कि थोड़ा बीच में से कट जा रहा है. Isn't it? You'll see that it's not passing tangentially to both the circle. Then there were one more. Kalpesh is it's 1 1 -1. Now again you see your -1 is where your base circle is staying. वहां पे भी आप देखें इसी पॉइंट को मैं अगर नीचे ले जाऊं, that again it's not on the base सर्कल पे वो नहीं लाई कर रहा है. This 1 1 -1 point also, because now your radius has become √2. If I mean that distance from this particular z axis, वो जो distance है वो बन जा रही है. The z axis is also the axis of your cylinder, isn't it? तो वहां से उसकी जो दूरी है x को x axis से 1 यूनिट है, y axis से 1 यूनिट है. So it would be lie on a radius, lie on the circle with radius √2. So if you make this as a -1 1 1 -1, then once again you will see that it's not lying on a cylinder with the base cylinder पे नहीं है ये वाला. And if I make my plane passing from 1 1 -1, then it would look something like this. ऐसा कुछ लगेगा. Something like this. Sometimes because it's a Zoom, YouTube, everything, then this machine gets stuck. All right. Okay. So now let me once again come back to my our initial thing which we have done. So हमने हमारे कुकुम्बर को काट तो दिया, अब इसका छिलका उतारना है. Right? What I want next is कि the way this so the way this particular So the way this cylinder has been chopped, what I want is, now I wanted to uh, when I wanted to remove the pill, what I wanted is कि the way this particular point is moving on the surface of the cross sectional surface है, वहां पे उसको मुझे move कराना है. And I also wanted to plot how its height is getting changed at the same time. ठीक है. तो एक बार मैं controlling of the 3D surfaces becomes trickier. सो आप इस पर्टिकुलर एंगल से देखें. सो व्हाट आई वांट इज कि ये जो आधा भाग है, ये वाला जो सरफेस है, वहां पे मुझे अपना पॉइंट मूव करवाना है, जस्ट लाइक हियर. सो when I look at, I want my points to be moved on the AB. One point B, preferably on the XY plane, जो सिलेंडर का आधी हाइट वाला, वहां पे एक मैं सर्कल ड्रॉ कर लेता हूं. मुझे एक पॉइंट बी चाहिए वहां पे, और दूसरा पॉइंट ए है, जो भी एक क्रॉस सेक्शन सरफेस है, वहां पे मुझे मूव करवाना है. राइट. सो व्हाट आई वांट इज, वंस अगेन लेट मी गो बैक हियर. आई वांट टू बी वन ऑफ द पॉइंट. So I'll draw a circle at the mid height of my cylinder, at the, let's say, with the center as an origin, and radius is same as what the cylinder has in radians. तो ये मेरा XY plane पे मुझे circle मिल गया, and I wanted to have a one point moving at this particular circle. Let me take one variable, let's say alpha, with value 0 to 2 pi. N, then one of the point to be moving on this particular circle, and the parameters for that are, the radius is 1 and the angle is also alpha. Right. And the moment I move this, तो मेरा जो एक पॉइंट है, if you are able to see the A point, थोड़ा zoom in कर लेता हूँ. So you'll be able to see this point A. थोड़ा कलर चेंज कर लेते हैं. So now I'm able to move one of the point. अब मुझे ये चाहिए कि जब जब ए पॉइंट है, ए पॉइंट से अगर मुझे कोई उसी के एग्जैक्ट नीचे, जहां पे ये सरफेस जहां से कट रहा है, वो वाले पोर्शन पे, दिस इज बेसिकली एन इलिप्स. इफ यू लुक एट फ्रॉम द साइड, so if you look at from the side, let me say that it's an intersection. Intersection between plane P and the cylinder A. और सिलेंडर को थोड़ा लाइट कर लेते हैं with another color. So your intersection part is this elliptical thing, जो पिंक कलर का है, वहां से वो इसको काट रहा है. तो मुझे चाहिए कि अगर ये जो ए पॉइंट जो कि एक्स वाई प्लेन पे रोटेट हो रहा है, ए एंड व्हाट इज द पिल पार्ट इज नथिंग बट ए से मैं अगर सीधा ऊपर ले जाऊं, वो जो पिंक लाइन वाली है उतना जो पोर्शन है, इफ आई वुड बी एबल टू get that part, what is that part, then I should be able to sort of say ki what will be the my let's say for example function, how this particular things is getting changed, then I should be able to tell that. The question is that how I would be, tell that, मतलब वो derive कैसे करें. तो next what I will do this is कि and this is, I wish I could have a longer time for discussions, but यहाँ पे मैं आपको solution की और ही lead कर देता हूँ कि कैसे इसको prove करें. So for now what I will do this is I will take uh, the projection of a plane, I mean a point A to this y axis. So what I will do is I'll take the x parameter of as 0, the y parameter is whatever A's points coordinate are there, and z is of course 0. So this would give me the y axis projection of the point A. उसको मैं फिर से हाईलाइट कर देता हूं. So now you will see that when the A point is moving, its y projection, which is basically it's saying कि उसकी ये जो x axis which is let's say for example a flat surface, तो x axis से उसकी दूरी कितनी है वो ये दर्शाता है point B which is moving on the y axis, which is nothing but the height, and height also gives you the so the change in the B would be with respect to the sine function, isn't it? अब मुझे ये चाहिए considering I'll create a triangle, I'll create a right triangle where the two vertices of a right triangle would be this AB, and the third would be where A's projection on the on this particular elliptical path. And question is, can you define what will be this particular the coordinates of what you say this pink line with respect to the alpha, where alpha is what, ये मेरा जो भी point move हो रहा है, the point A, ये जो भी move हो रहा है, so ellipse if you look at from the top it would be a circle, isn't it? अब मेरा यह जो point A है that is moving मतलब वो ऊपर से आप देखें तो with respect to x axis it is moving at a theta angle. मुझे ये चाहिए जहां से मैंने काटा है वो वाली जो सरफेस है वहां पे एक और पॉइंट ले लूं. सो माय ए बी, I mean my A and that particular point P will give me, AP will give me eventually the height at a various angle, and that I wanted to prove it's a part of a sinusoidal function. वो जो height है वो जो change हो रही है, if I can show that that's as a part of a sinusoidal function, then I will eventually able to prove कि ये जो छिलका मैं जो उतार रहा हूँ वो भी एक sine function है. Question is that how can I do that? How can I derive that particular parameters? Excuse me for that. Now, which also leads to, can I find how the point which would be eventually moved to my elliptical path, the cross sectional path, उसको अगर मैं उसके XYZ parameter अगर ढूंढ पाऊं, then I will be able to, with respect to the alpha, then I'll be able to sort of see कि इवेंचुअली एपी की हाइट कैसे चेंज हो रही है. तो अगर उसके पैरामीटर्स में देखने चाहूं तो x और जो y पैरामीटर है विथ रिस्पेक्ट टू अल्फा, दे वुड बी दी cos अल्फा एंड sin अल्फा, इजंट इट? उसके जो xy पैरामीटर है वो तो cos अल्फा sin अल्फा होंगे. क्वेश्चन इज हाउ इज द z is changing, which is also the height of that particular point, how that is changing, and that z is nothing but the distance between the A and the elliptical path. Can somebody tell me how can I get that particular height? Any thoughts on it? How the, let's say for example, and what I'm interested is उसके पैरामीटर ऊपर से देखें, which is just the xy projection, तो वो circular path में ही move हो रहा है. Ellipse from the top would be nothing but a circle, which is cos theta sin alpha. I mean cos alpha sin alpha. That तो we know. Question is about the z parameter. Z मतलब ये जो pink वाला path है, उसकी कहीं पे height कम है. If you look at from exactly this, the whenever this angle is 0, then you would say that the height is maximum. It's 1. When the angle is 90 degree, तब point यहाँ पे आ जाएगा जो पिंक वाले पाथ पे है. Then the height would be 0. Then once again at the angle pi, it would go to the -1, the height, and once again it becomes 0, and so on. The question is, how can I derive the height of this particular point? Any thoughts on that?
Tan alpha, sir.
Tan alpha. And all right, so let me try to write that. So let me write this as in cos, that value, the cos is alpha, the x parameter is cos alpha, the y is sin alpha. This is for sure, because if you look at from the top, it's nothing but a circle. So that's why cos sine. The z, we are saying that it would be the tan alpha. And if I run this, because you see the max value and the minimum value it can have will be the -1 to 1. It should vary from that. Now 10 eventually actually goes to an infinity when it reaches to the 90 and pi by 2, and you can see that this point C is certainly not going to my elliptical path. Any other thoughts? Any other options?
Cos alpha plus sin alpha, sir.
Cos alpha plus
Sin alpha.
sin alpha. So along with this trying the function, maybe Sandhya ji, we wanted to think ki what is the base for that argument as well. मतलब one तो this tool can give us a luxury कि भाई जो डालना है डाल के देख सकते हैं, but it would be nice to also think why that is the truth. Okay, so we wanted to see that it's a sin alpha plus cos alpha. Okay, and let's see what will be the output. Now you will be see that the function C is also certainly not moving in the way we want it. Sometimes its height goes beyond the value, I mean the height of a cylinder, and it's even going bottom and also not matching with what we wanted. So all 3D geometry problems. So here what I want is कि वो जो 3D में वो जो elliptical path है उसकी height कैसे change हो रही है वो derive करना है. So all 3D problems, how do they are getting visualizes? Can I convert it into in 2D? Now, the moment you have converted into 2D, there is a lot of formal things we have learned in the 2D कि भाई कैसे करना है, उसकी values कैसे निकालनी है, trigonometry से, right triangle से, Pythagoras से, that we know. Question is that can I convert this 3D problem where एक ellipse है जो कि 3D plane में है, उसकी ऊंचाई कैसे चेंज हो रही है, z पैरामीटर कैसे चेंज हो रहा है, so can I convert that into an 2D thing? Let's say for example, can I find a triangle such that it's uski, let's say certain things I know, and the third value I'll be able to get that. Can I do that? That's the question. Yeah. Any other, somebody has any thoughts? ये वाला जो point है इसका z पैरामीटर क्या लिखें ताकि जो ऊंचाई कैसे चेंज हो रही है वो हम निकाल सके, या how can I find that at all? All right. So I'm left over with a limited time. So now let me try to show how preferably we would like to sort of calculate it. Okay. Let me see if I can show it here. So then I would request you to look at this right triangle. A right triangle which has been formed by this point A, which is where it's lying on the ellipse. Its projection on the xy plane, which is this particular B point, and another one which is moving on the y axis. ये तीनों से जो right triangle बन रहा है उसमें मुझे क्या ढूंढना है, मुझे ये वाला जो लाइन वाली लाइन है वो ढूंढनी है, which is basically the height. What I know about them is if and what would be this particular angle? Can somebody tell me this particular angle? Let's say AF and B. Let's say the angle between this particular A, this and this. Can somebody tell me that? इसमें दिखाते हैं तो ज्यादा बेटर रहेगा. So what I want is कि so if I take a point, let's say for example, so this AB, now visualize that there is this point on this particular ellipse, which I would call as P. So this PAB will make a triangle. My question is, what would be the angle formed by the, what will be that angle PBA? Because that angle I actually know that is the same angle at what you have made the cross section. So that particular angle as of now is a 45-degree angle, isn't it? ये वाला जो आपने जो काटा है plane, I'm facing challenge because this computer is getting stuck. Sure. and first let me write that so that you are able to see. So what I wanted to show you is, just a second. So look at this point, and let me call this as a P. So if you only look at my point P, as we have discussed, it's because it's moving in a circle. If you look at from the XY projection plane, तो उसका cos theta sin theta तो समझ आ जाता है. Question is that how does the height is getting changed? That is what we are interested is in. So and if you look at, so what we are interested is in, if I look at the right triangle formed by these 2 points, which is P A B. This is the right triangle I'm interested in. Question is, I'm interested in getting derived the value of this PA, which is the height of P. P का मुझे x और y तो मिल गया, मुझे z ढूंढना है. तो ये वाला जो right triangle है, question is, can I look at this right triangle and can I know, can I get the value of PA using some trigonometry or some properties? So eventually it's a right triangle. तो क्या मैं कुछ पता हो तो उससे निकाल सकता हूं क्या? So then the question is, one thing I know for this particular thing is this angle PBA. Have a close look at this particular angle PBA. That is the same angle at where your cross-section plane is cutting. This line PB is lying on the cross-section plane. I'm not sure whether you're able to visualize this or not. तो ये जो right triangle बन रहा है, उसकी one of the angle is the same as द योर बेस ऑफ द सिलेंडर एंड द क्रॉस सेक्शनल प्लेन, वो जो एंगल है, जो एक्स वाई प्लेन और मेरे प्लेन के बीच का जो एंगल है, वो सेम ही एंगल PBA का है, and which is constant for a, and so we are deriving this for a given cross sectional angle, so that is constant. So if I can get the value of one of the side, then I know one of the angle, and using, because it's a right triangle, so I can derive the side PA. मुझे अगर ये ट्राइंगल PBA, what are these 3 points? P point is on the elliptical, where on the cross sectional curve it is there, it is on the ellipse. What is the another point? A is the projection of that on the xy plane, which is the circle. What is the point B? A point का y एक्सिस पे प्रोजेक्शन है पॉइंट B. ये जो तीनों जो ट्राइंगल बना रहे हैं, उसमें मुझे एक चीज पता है. क्या पता है? एंगल. This angle PBA is the same angle as the plane angle. And why I have chosen this particular triangle? Because I wanted to use certain known properties. I knew that this cross-sectional angle is a constant. I wanted to utilize that to derive the value of PA, which is the height. तो इसलिए मैंने ये वाला ट्राइंगल बनाया है, ताकि कुछ एक चीज कांस्टेंट रहे. तो अगर दूसरी कोई भी एक साइड लेंथ भी मैं अगर निकाल लूं, तो मुझे जो मेरा PA वैल्यू है वो मिल जाएगा ट्रिगोनोमेट्री की वजह से. सो इफ आई कैन नो द वैल्यू, if I can get the value of AB, then my 10 alpha says that 10 alpha is nothing but an opposite side, which is PA upon the side AB. 10 अल्फा का सूत्र बताता है ये सामने वाली साइड अपॉन जो पास वाली साइड है. सो विच इज PA अपॉन AB, दैट इज द 10 अल्फा वैल्यू. माय अल्फा इज 45 डिग्री हियर, विच इज 10 अल्फा इज 10 45 डिग्री इज 1. सो वो वैल्यू मिल गई. इसका मतलब कि AB की वैल्यू और PA की वैल्यू बराबर होगी when the cross sectional plane is 45 degree. It would be change, it will change if this angle is getting change. इन दोनों के एंगल के रेशियो के ऊपर ये डिपेंड करेगा. अच्छा, AB की वैल्यू क्या है? कैन एनीबडी टेल मी व्हाट विल बी द वैल्यू ऑफ AB? कैन somebody says me?
P
Can anybody tell me then?
PB sir.
PB sir.
PB.
Yes, it will be. हाँ,
PB.
so PB is the hypotenuse of my right triangle. So we can get that value, but my interest is in right now is a PA for the 45 degree 10 alpha, for a 10 45
AB
degree, which is
equal
1.
to PA.
AB equals to PA. So this is an isosceles triangle, isosceles right triangle in the case where the cross sectional angle is a 45 degree. Now question is, can somebody tell me what will be, how can I get the value of AB? Mind well, I know the A is moving with respect to theta, or the alpha in our case, where alpha is nothing but the angle formed by, let's say, A को अगर मैं origin से जोड़ू, तो XY प्लेन के साथ वो जो एंगल बनाएगा, that angle is what उसके रिस्पेक्ट में मुझे चाहना है, क्योंकि that is the only variable. So if I draw a segment between origin and the point A, this is ये जो काला वाला लाइन है, let me hide the other. ये जो काला वाला लाइन है, उसका जो एंगल है विथ रिस्पेक्ट टू ओरिजिन, दैट इज व्हाट द अल्फा वेरिएबल इज. वो एक ही वेरिएबल है. ये पूरा जो P पॉइंट जिस तरह से मूव कर रहा है, उसमें एक ही वेरिएबल है, एंगल. एक्स वाई के साथ वो जो एंगल बना रहा है, वो अल्फा बोले, थीटा बोले, जो भी बोले, वो मुझे पता है. अब मुझे जो AB की वैल्यू है, आई वांटेड टू फाइंड द वैल्यू ऑफ AB विथ रिस्पेक्ट टू दिस अल्फा. ये जो AB की वैल्यू है वो मुझे लाना है. Can somebody tell me, and assuming the radius is 1, can somebody tell me what will be the value of AB with respect to this angle alpha? This is nothing but considering the black line as an hypotenuse. So now assume this right triangle which is formed by OAB, another right triangle on the xy plane. And for this right triangle, the hypotenuse is constant, which is the radius of the circle, radius of a cylinder, that is constant. Your angle you know is theta. Your AB is nothing but an opposite side, isn't it? And how can I get an opposite side in a right triangle? It's a sine function. And we have just, whether you are starting from the zero value or the max value, just based on that your sine is a phase difference, pi by 2 hai, and that's how I can prove this particular point P is moving in a, its height is changing in a sinusoidal function. And this is what how P is defined. तो जब जब ये एंगल, when this angle is zero, this angle is zero, this point P is in the bottom, the value is -1. So it's starting from the 1. That's why instead of sine alpha, I mean, I have taken sine alpha plus pi by 2, which is basically the cos function. So cos and sine are just phase different. And because it's starting from the -1 at the alpha equals to 0, that's why we have put this value as a negative. So the coordinates of P are cos alpha, sine alpha. These are its x and y parameters, and the height is changing with respect to sine function. Now, if this and we can, if we wanted to shift this entire cylinder towards, let's say, its base circle in the xy plane, then everything would be just shifted, but the sine function would remain constant. Even if you change your cross-sectional angle, and that is what the homework question for you is, chop the cylinder at a various angle, and can you get this particular let's say this coordinates of P with respect to various cross sectional angle. अलग अलग एंगल से इसको काटे तो क्या अलग अलग वैल्यू आती है, वो हमें मतलब क्या वैल्यू आएगी वो आपको डिराइव करना है. So this one term which is one here, which remains. So here another term would add, which is nothing but the tan function, and this particular angle would be जो भी angle है आपके plane का, this would be the one. Now because it's a 10 pi by 4, anyway. So this is what your the proof part of it, कि how come your when you are chopping it, or the formal proof of how this height when you are unwrapping it. So when you are unwrapping it, the only thing with respect to your angle theta, so your, अगर आप इसका bottom देखें, so when you are moving this particular point on a on the pill of this cucumber, तो आपका ये जो बी पोजीशन जैसे चेंज हो रहा है, दैट इज नथिंग बट सर्कल को हमने सीधा कर लिया. ऐसे ही मान सकते हैं, जो पॉइंट बी है वो तो सर्कल में घूम रहा है, उसको हमने अगर फ्लैट कर दिया, सो इट इज नथिंग बट जो सर्कल का वाला धागा है, उस धागे को मैंने एक स्ट्रेट लाइन में रख लिया, एंड दैट वैल्यू वुड बी it's a 2 pi r, assuming r is 1, that would be 0 to 2 pi, and that is nothing but how your theta is getting changed. Your x coordinate is nothing but your theta moving from 0 to 2 pi. The question is, how is your y parameter is changing? That is nothing but a given angle. How much is the height of this particular point A? In our case it was P, that is changing with respect to a sinusoidal function. यहाँ पे हमने क्या कर दिया है कि ये वाला जो पूरा छिलका है, इसका यहाँ पे जो एक्सिस था, so eventually in the curve, there's this sine wave, but just shifted half of its amplitude. तो लेट्स से इसी को अगर मैं 0.5 पे लाइन बना दूं एक्स एक्सिस पे, दिस वुड बी द सेम एज द साइनसॉइडल फंक्शन व्हिच वी यूजुअली ड्रॉ. ऑलराइट, ठीक है. बिट ट्रिकियर वन, but I hope I'm at least able to sort of able to communicate that how do you visualize certain things, or how do you prove certain things in a 3D. तो वो कुछ काटा, उसको खोला, तो साइन वेव जैसे दिखा, वो तो एक अलग बात है. but can we prove it, the things which we say. So one, as a homework exercise I would like to do is, एक सिलेंडर को काटिए और उसके इलिप्स के दो फोकस पॉइंट्स हम ढूंढते हैं, दो फोकाई ढूंढते हैं. एंड हाउ कैन आई डू दैट? ड्रॉप वन sphere from the top. Once again, push one sphere from the bottom. Make sure that you push it till the where it touch to the plane in tangential manner, so as from the bottom. तो वो आपको ट्राई करना है, और इस प्लेन का अलग अलग एंगल पे वो क्या क्या उनकी स्फीयर की पोजीशन होती है वो करना है. The second homework is make a cross section of this particular cylinder at a various angle, and try to get this particular point. ये जो क्रॉस सेक्शन सरफेस है, जो इलिप्टिकल सरफेस है, वहां पे एक पॉइंट को मूव करवाना है, और उसके एक्स वाई और जी पैरामीट्रिक इक्वेशन लिखने हैं. You can of course find that intersection using an intersect command. You can get the intersection of that plane and a cylinder, और उसके ऊपर point command से तो घुमा ही सकते हैं. But we wanted to write it in a parametric way so that I can prove that change in the height is of a sine function. थोड़ा हो सकता है कि ये आज का ट्रिकी गया हो, but the idea was to keep on upgrading our challenge. And for the next week, maybe we wanted to look at or discuss the things. If you have any doubts, we wanted to resolve that, and wanted to also share you some of the rich resources from where you can keep on making some interesting projects. Once you start developing, it's a very addictive process, and yeah, show you some of the cool projects which we couldn't do in the course, but maybe you would like to work on that. Yeah. Any thoughts, any doubts, anything you have in mind to ask? So Rishabh says that कि इसकी क्या कोई regular class चलती है क्या? So from last 9 weeks, we are meeting every Thursday, and the idea is to keep on creating some cool projects. There would be one more on the next Thursday, same time, 9:30 p.m., same link. And after that, we wanted to start a course on computational thinking using spreadsheet. Microsoft Excel या Google Spreadsheet के माध्यम से we can do some very interesting arithmetic, algebra, and computational thinking part. So that's we wanted to start a course, and soon we'll make an announcement. Maybe I'll take some breath in between. We'll plan the sessions, and then we can start that. But good to see that so late you are taking an interest and time to be part of this particular sessions. Yeah. All right. So Suyash is saying that will this be helpful for college student? I would say this visualization exercise in a GeoGebra can be a very useful and powerful term. So we have made few interesting engineering or undergraduate level applications out of this, where the base is 2D and 3D geometry. So this is the foundational level thing we wanted to see कि 3D geometry में कुछ ढूंढना है, करना है तो कैसे करें, 2D geometry में कैसे करें, how do we prove this stuff, how we can have an interdisciplinary way of looking at the algebra and geometry. That was the goal of this entire course. So I would say it would be interesting for an undergraduate students as well, depending on and what you are looking at. So I personally feel it's equally applicable for the maybe 9 to 12 graders, their educators, so as for the undergraduate and further studies as well. A lot of stuff we have created. which we have shared with the undergraduates in IIT Gandhinagar and postgraduates as well. All right. जी, किसी का कुछ सवाल हो, किसी को कुछ पूछना हो, शेयर करना हो, अदरवाइज ओके. ऋषभ इज सेइंग कि रियल प्लेन से एस प्लेन, लाप्लास प्लेन एंड आइंस्टाइन स्पेस टाइम कर्व के रिलेटेड क्या है. So I have not worked on the few other dimensions like time and other, and doing that I have not personally done it anything. I'm not sure about in the lab if we have done anything. About the Laplace transform and the Fourier and Laplace frequency domain or जो Fourier transformations है. So especially in the Fourier transformations, we have done certain things, built some applications on that. I let me try to see if I can demonstrate that in at least the last session. So may not be the detail of it, but at least the glimpse of that we would like to show. With the Laplace and other things, we have built some of the sound and wave related stuff on top of that. Maybe not scope of this particular course, but yeah, eventually we can share it in some format. I wish we can share. Yeah. जी. और किसी का कुछ सवाल? नो? All right. ठीक. So thank you. That's the comment. All right. Sure. बहुत बहुत धन्यवाद आपका for staying such a long and no, stay tuned in such a continuous manner. I personally have enjoyed such an interactions. Can you please single cut alphabet A to Z video share with us? हमने इसका टेम्पलेट यूट्यूब चैनल पे डाला हुआ है, where we have shown how to make a valley and mountain fold. कहाँ पे खड्डा करना, कहाँ पे माउंटेन वाला फोल्ड करना है, वो वाला दिखा दिया. इफ यू गो एंड लुक एट द सिंगल सिंगल कट वीडियो, तो उसमें आपको दिख जाएगा उसको कैसे फोल्ड करना है, वो वाला. आई एम नॉट प्रीटी श्योर अबाउट दैट कि उसकी वीडियो हमने बनाई है, बट होपफुली वो फोल्डिंग मेथड से हो जाना चाहिए. If we wanted to look at the single cut from a very basic, looking at the square or maybe a square grid, चेस बोर्ड है, उसको कैसे सिंगल कट करना है, अलग अलग शेप कैसे करना है. सो वी डिड वाज एंटायर वंस आवर सेशन ऑन द सिंगल कट, जिसमें हमने वो समझाया था. इफ यू लुक एट द क्यूरियोसिटी सिंगल कट, you would be able to see that one of our colleague did the episode on that. Yeah, thank you उपमा जी for joining. जी. और किसी का कुछ सवाल? नो? ठीक है then, maybe. So you can drop an email to us, Rishabh. I am writing our email ID, which is ccliitgn.ac.in. Also wanted to announce that we are doing this open workshop from 21st of May to 24th of May, and anybody who is interested are most welcome. For the student, the registration fees is 2,500. For any educators or any other professional or any freelancer, the registration fees is 5,000 rupees, which includes their food stay and everything. उनका 4 दिन का खाना पीना रहना and everything is included in this registration fees. Would be more than happy if any one of you would like to come and be part of this workshop. So the goal of this open workshop is कि ज़्यादातर workshops होते हैं वो और some specific target audience के लिए होते हैं. The goal of this open in-person workshop, यहाँ पे IIT गांधीनगर campus में offline workshop चलेगी, where we wanted to talk about interesting mathematical and scientific things. The idea is to how we can make our curriculum more inspiring and maybe engaging and interesting. That's the idea. So anybody who wanted to be part of it can drop us an email and we can share. We'll be more than happy to share the details for the same. Yeah. Okay then. See you next week. अगले हफ्ते आपसे मुलाकात करते हैं next Thursday maybe. Okay, bye bye.